What is going on YouTube? It's me, the Redstoner here, and today we're going to look at our second guide in Redstone. This is going to be part 2 of our series. I want to review what we did last time. Last time was basically just talking about Redstone physics, basically, vertical transmission, stuff like that. And if you haven't seen the first one, I would like you to look at it because I'm going to reference it a few times, talking about how this section works. This section is called logic gates. And what logic gates are in Redstone is they're basically the electrical engineering names we give to certain things. So basically, we have certain inputs. Say this lever is an input, is going to give us certain outputs, and the outputs are going to be black, of course. And if you remember, gates are gold, so you're going to see a lot of gold everywhere. But basically, what this does is it's going to say like, okay, we're going to have this lever and this lever, in certain position, and maybe this other lever is not going to be in that position. Then what will be our output? And you can get whatever kind of output you want by choosing different gates. And we have a bunch of different gates. We have the NOT gate, we have the OR and NOR gate, and a NAND gate, XOR and XNOR gate. And these are going to be kind of crazy to kind of look at, but hopefully you'll be able to understand them. This is the very basic stuff. The first 2 or 3 gates are going to be really easy. Pretty much this is the NOT gate. As you guys remember, we call this an inverter. And what a NOT gate does is it takes a signal that's off and turns it on, or it takes a signal that's on and turns it off. And this is great where if you just basically wanted it where you'd have to keep the lever like this the whole time, but you don't want to, you can go ahead and invert it where it's going to be on when the lever's in the off position. Where usually you'd be having it down like this all the time, and you just don't want to do that. It's also great for a bunch of other things. So basically, all redstone logic is based off this gate right here. If you don't understand this gate, then you're not going to be able to understand anything else. It's probably the most important gate in redstone, even though it's so simplistic. And basically, we also call these inverters, of course, but every time you see a torch, that is a NOT gate or an inverter. Pretty much every time you see a torch. Whenever we use torches, we're using this gate. And you can actually go ahead and make double NOT gates with them, or double inverters. And what this does is it takes a signal that's on, converts it back to off, and converts it back to on again. And you can actually make basic locks out of this, like I showed you in the last section. But usually, what we used in old redstone times was this is actually how we extended redstone streams, if you went too far. Because notice how if it's off, it's giving me an off signal. If it's on, it's giving me an on signal. So this reinverts it twice, where it turns this off to on to off. And by the way, in binary code, which we're going to look at later on, when you have a signal of 0, it's off. And when you have a signal value of 1, it's on. So basically, this is saying we're putting in 0 and we're getting out 0. We're putting in an off signal and we're getting in an off signal. And we're putting in 1 right here. We're putting in an on signal, and we're getting out 1. We're giving off an on signal. Now this is the next gate, as you can see, the OR gate. And the OR gate is really simple. It's just 2 pieces of redstone wired together. And whenever you see redstone wired together, it's actually an OR gate, which you may not be used to seeing or calling it that, which really, I really kind of stopped thinking about it like that a long time ago. But it's just kind of important because sometimes you'll see schematics where it says put an OR gate here, and you'll realize that you have to wire these together. But basically this says that if any of the levers are on, our output is going to be on. So as you can see, of the 4 basic combos, the only one that gives us an off signal is this. So basically, if we have zeros from both our inputs, we're going to have a 0 for our output. If we have a 1 for any of our inputs, we're going to get out a 1. And this is basically just to show you that we can wire multiple streams together at once. This is 3 different streams, but you can really add as many as you want, as long as none of the streams are more than 15 blocks away from the output source. So if any of these are on, it's going to turn it on. And this is basically like, let's say there's something in your house that you want to be able to control from any of the different levers throughout your house. You just wire them all together, and you hit it together. That's what OR gates do. And NOR gates are basically NOT gates and OR gates put together. So they're basically an OR gate, as you can see here. They're wired together in an OR with a NOT gate right here, and that's a NOR gate. And what that NOT gate does is it reinverts it where it's always on unless any of these levers are off. So basically, if you have something running all the time and you want to have a kill switch for it, where you can pretty much stop it from anywhere in your house. Like, let's say you had a mob grinder and you wanted to turn off the killing mechanism for it, you can turn it off from anywhere in your house by hitting these switches right here. And that's what that's good for. And it's also used in a lot of different circuitry later on. But basically, anytime you see an in front of a gate name, it's going to mean add a NOT gate or remove a NOT gate. And since there were no NOT gates in an OR gate, we can only add one. Now this is an AND gate, and it gets its name because it's saying that not only does this lever have to be on, and this one has to be on as well. And basically what this does is, as long as both the levers are giving off ones, this will give a 1. But if any of them are giving off zeros, if any of them are off, then this is not going to be on right here. And what this will allow us to do is actually do a lot of really interesting things. You see this in a lot of circuitry. But I want to kind of break this down for you, where basically we have this input, and that's going into a NOT gate, and this is going into a NOT gate, and both these NOT gates are giving off signals into a NOR gate right here. Because you see this is NOR, because it's OR because they're wired together, and NOR because it has that NOT gate added at the end. And basically what this is saying that whenever this middle piece turns off, it'll allow this torch to turn on. But since both of these are wired into it, both of these have to turn off in order to allow that to turn on. So as you can see right here, just very fancy magic with the redstone, where basically both of them have to be off. Now, what we can also look at with this is another way where we just have the lever kind of going into it, where both of them still have to be off, but the lever can be directly on the block. And I actually broke this down into the NOT gates and NOR gates so you can see it better. As you can see, it still works. I would use the first design I showed you just because that is the most compact, and compactness matters a lot in Redstone. But pretty much as you can see, it's just a NOT gate and a NOT gate, and both these NOT gates wire together to a NOR. Now, it doesn't matter how many levers are in the NOR gate. You can have as many levers as you want. So I put 3 right here. Personally, you could probably go up to 15, or really you could go up to 30, because you'd have a redstone piece in each direction coming in and out. Basically, as long as all these are off, it turns on. So basically, let's say you had a piece of TNT and you wanted a safety switch. So it's like, okay, we have to hit one lever over here. This guy has to give the okay, and this guy has to give the okay, and it'll power the TNT. Like maybe like a self-destruct for your house, and you want it to be where, you know, someone can't blow up your house. I don't know why you'd want a self-destruct, but but I've seen people put them in. So so that's kind of interesting. And right here, you could say we just wire them together. If you remember from the last section, if we have a redstone, repeater redstone, we can actually have individual lines separated from each other going in like that. So basically this just powers each torch individually, and if all of these torches are off, it's going to allow that to turn on. And only if all those torches are off, meaning all these levers are on. And we're also going to look where it's just powered directly into the block. That's another good way to kind of separate out the signal. And this is actually going to show you some vertical transmission ways to do it. I just want you guys to be able to recognize different AND gates, because you're going to see them in a bunch of different places. So I want you to be able to kind of recognize them, where, let's say you have a lever right here, where basically we are separating out all these signals, and all these are NOT gates. Powering up here, it's actually going to this torch, which is a NOR gate. So as all these are on, it's going to allow that to turn on as well. And you can also do vertical transmission where you have the torch on the back of the block. So as this block gets powered, it turns that torch off and powers up this redstone stream, which goes into this NOR gate and powers that. Or it goes into this redstone stream, goes into that NOR gate. So as you can see, both these have to be on, but it turns both these on right here. And all that magic. Now this is just the NAND gate. As you guys remember, NAND is not AND, meaning that we just either add an inverter or remove an inverter. In this case, we removed one, the one on front of the block. You see right here, we usually have a torch, but we don't have one right here. And this basically says that this is always going to be on unless both of these happen to be in the on position, then it's going to turn off. So that's if you wanted to kill switch for something. Again, basically if you just were getting out a signal and you wanted to invert it. Now, we have the XOR gate. This, guys, is going to be our longest section and our most complicated, so please sit down. This is what I really suggest you getting into a private world like this and kind of just setting up a flat world and tinkering with. Again, tinker with all of these as well, but especially XOR gates, because they will not only expand your understanding of Redstone, but they're also quite cool and all that, and they're really my favorite gate, just because of how fun they are. And this is the basic design for the cheap XOR. You can have a slightly more compact one, but I'll show that to you in a second. And just notice this layout where you have torch, 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 redstone right here, another torch, 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 and redstone. And all this powered out of it. And it gets a little confusing, but basically what this does is saying that if any of these are in the wrong position, or if they're in the same position, it's going to be off. If they're in different positions, they're going to be on. And what this actually does is, like, let's say we have something that's on in the room, like you have lights in a room on in your house. Well, if you flip either switch in your house, it's going to turn off. So let's say if we flip this one, it's going to turn off because they're in the same position. Or if we flip this one, it's going to still turn off. So no matter which one you flip, it's going to turn off. So this is useful where if you have something that you want to be able to control finely from a bunch of different levers, or somewhere else in the house, where let's say you have one lever over here, in two separate rooms, but you want both of them to be able to turn something off at any given time, this is how you would do it. And it's pretty simplistic once you actually kind of get an understanding of it, but you really do need to break it down so you can understand it and all that. And this is actually how your lighting in your real house works. You know, if in real life, you know, if you flip a switch, then if you flip a switch on the opposite side of the room, it's still going to turn the lights off and stuff like that. So, pretty cool. And this right here is me breaking down it into just NOT gates, which I thought was pretty cool. But basically, you can see, this is why I said NOT gates are super important, because they make up everything in Redstone. All of these are just NOT gates, but they will give us the same signal. Look, and I had to space it out a bit for timing, but notice how both these are in the same position. It's still going to be off. And if they're in different positions, it's going to be on. So let's go ahead and talk about how this works, because I want you guys to understand how XORs work. And I built a few other schematics right here to show you a bit more simplified version. But as you can see right here, basically this goes, I want to follow each stream. So this goes into this line. So this is a double inverter right here. And this double inverter is actually pretty important that it's a double inverter, not just a line. And this double inverter is going to feed into this block right here. So it's actually going to get triple inverted. And if, as you guys know, if it's an even number of inverters, it's going to give the same signal. If it's an odd number of inverters, it's the same thing as one inversion. So this is going to be like triple inverted down to here. And our goal is we want one of these to turn on at any given time. Or I don't think you can actually get them both to turn on with this design. But if one of these torches turns on, it's going to give this output. So what's stopping it is primarily this needs, or right now, this AND gate is stopping it, which actually, as we go from here, this actually gets double inverted, and this double inverter goes into this AND gate, and this AND gate's gonna go back into those, because this actually goes into a NOR. As you can see, this is an AND gate, because it's not, and then NOR. But as it gets double inverted, it goes into a NOR gate, and then this goes back into the same signal. So basically, this AND gate right here is keeping these torches off. So if we ever flip a switch, what's happening is this AND gate's no longer on. But because this is inverted, this torch is now stopping that. But this one over here still hasn't been flipped, so it's not stopping it either. So it actually allows it to turn on. And if we flip this one, now even though the AND gate's off, both of the torches are stopping the signal, making this where it can't turn on. I know it's confusing and complicated, but please bear with me, because this is by far one of the most fun ones to understand. I highly recommend you go play with them and see for yourself. And I broke it up into two different designs where I was just kind of tinkering with, let's see how compact I can get this thing. But basically right here you'll see that we have our basic inputs where we have this NOT gate going into a NAND gate. because when these NAND gates actually come out, they're going to get inverted again, so that's going to make it an AND gate. But as you'll see, it goes right here, and then these both go into an AND gate because it's not and a piece of redstone. And both of these are wired into the signal. And this works as well, where if you flip either one, it's going to change the signal. And this is my most compact one that I designed myself. These are designs that like that one over there is a design I got from someone else, and so is that one. But this is probably the most compact design I made myself, where basically you'll see, I just want you to kind of recognize where if one of them's on, even though this torch is on and this AND gate's off, this one is still off as well, so it allows it to be powered. And if they're both in the same signal, what's usually happening is this middle torch is keeping them both off. So it's very important to kind of understand that, because it allows you to kind of understand redstone better. Now, this is by far the most compact XOR I've ever seen. It's one block less in length than that. It's just a little bit more expensive because it has repeaters, so I don't use it too much. But basically, as you can see, if we ever have this, it's allowing it to turn on. But if they're ever both in the same position, it's actually having this middle torch turn them both off. So this actually takes the philosophy that we're going to make this not a NAND gate, but an AND gate instead. And the AND gate is going to, let's control stopping it off. But basically it's just rearranging the inverters, where we have 5 inverters right here. And these repeaters are made just to keep this line separated from the rest of it, because if we had redstone, it would actually get wired together. Now, that we made a compact one, I want you guys to kind of see these 4 wired together right here are actually all one circuit, where you can wire it all into that single block. And basically what you see here is I have an XOR, get wired into another XOR, and this XOR gets wired into another XOR, and goes out like that. And what this does is if any of these levers swap places, it's actually going to change that redstone. It doesn't matter which one I flip, it's going to change its signal. I can turn this one back off. Turning on. I'm not like measuring out. These are all just kind of random levers that I'm flipping. And notice how it's just changing signal. And notice how long it takes, by the way, because in the last video, again, I talked about you want less ticks. Now notice how many ticks we have here. We have a tick here, 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 tick, 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 tick. And basically, every single time you're adding one of these, it takes another 3 ticks at least to change the signal. So you'll notice how it kind of cascades down. So as you add more and more XORs, it's going to get less time efficient. That's kind of an important thing to understand, even though you will be able to accomplish a lot of cool redstone stuff with it. As you can see, so the more compact versions are usually favored. But this is where again, if you wanted from anywhere in your house to be able to control something, you'd have an XOR, and then all this going into another XOR. And so on and so on. You can just chain them together. And by the way, if you wanted to make this just a lever, like if you wanted to have 3 inputs, you could have one of the XORs could be in, like, you have one XOR leads into another XOR, and then just a regular lever going into that XOR. And then no matter which one of these you change, it's still going to alternate the signal. I just thought that'd be kind of cool to show you guys. And then right here, we're going to get into the NAND gate. Or the XNOR gate, I mean. Don't know why I said NAND. I've been a little fried. But what this is the not XOR gate, or exclusively not OR gate, which this is called the XOR because it's exclusively OR, which is how you get the name. And don't ask me to explain it to you because it's kind of complicated. But this is called the XNOR gate. And as you guys remember, if we add an N into it, usually it means we're adding or subtracting an inverter. Well, in this case, what we're doing is we're adding an inverter to this and actually making that kind of an AND gate at the end. As you can see, it's always on unless either of these are turned off. So basically, this will just allow you to kind of swap the position, as you can see. But it's pretty simplistic in the way that it's actually laid out. You guys just need to understand that we're just adding a NOT gate. And this is our first XOR layout, and we're just adding another NOT gate. Which this is the kind of the version I used a lot before repeaters ever came out into Minecraft. But that's pretty much been it. I'd like to thank you guys for watching, and have a great day. I just want to review. Basically, we talked about all the gates and talked about how each of them, if you choose different gates, you can get different outputs based on your inputs, and that can allow you to wire out different things around your house. and it'll be very useful for understanding future projects that I'm going to show you guys here on RedStoner. I hope you guys had a great day and learned a lot, and please go into Minecraft and try all this out yourself, and please feel free to leave comments and recommendations, stuff like that you want to see in these videos. But again, thanks for watching, have a great day, and I'll see you guys later.